Hello everyone. We are going to go over polar coordinates. You might be asking, what are polar coordinates? To understand that, we have to look over the difference between rectangular coordinates and polar coordinates. Now, rectangular coordinates, you might not be familiar with this term, but you might be familiar with how it's written. It's, it's written as an x value and y value. And as we all know, it is graphed on a Cartesian plane with the x-axis and the y-axis. The x-axis is the horizontal axis, and the y-axis is the vertical axis. Now, on the other hand, polar coordinate, it's a bit different from rectangular coordinate. Instead of being written as x and y value, it is written as r and theta. Now, r is the radius of a circle, and theta is the angle measured from the positive x-axis. And this is graphed on polar plane. The polar plane is a plane with a bunch of concentric circles. We know how to use rectangular coordinates, but today we're going to see how polar coordinates work. Now we will look over some examples on polar coordinates and how you graph them, just so that you can get a bit of an understanding on how it works. So as I showed before, polar coordinates are written in r and theta. R is the radius, and theta is the angle measured from the positive x-axis. And what do I mean by this? So, so this, so this is the polar plane with three concentric circles. Go to the center, and as we know, this is the x-axis. This is the y-axis, and this is the positive, and this is the positive x-axis. And if you want to measure theta, we start from here and then we go counterclockwise. Let me show you an example. Let's say I tell you to graph 2, comma 90 degrees. So first, 2. As we said, polar coordinates are written in r and then theta. So r is the radius of our circle, theta is the angle. So here radius is 2. So we start from here and then we go 1, 2. So the point is somewhere on the circle. So we see the angle theta. Theta is 90 degrees. So as we said, we start from here, the positive x-axis. We start from here and then we get counterclockwise. 90 degrees is about here. Somewhere right here. So our point will be here. How did we get that? 90 degrees and then 2, meaning on the second circle. Let's try another example. All right, so let's say I say 1, comma, let's do 60 degrees. So 1 and radius, so we go from this to the first circle, and then the 60 degrees. Let's 60 degrees is about about here, with the 60 degrees right here somewhere. So our final point will be right here. As you can see, this 1 means the first circle 1 unit away from the center, and this 60 degrees means angle starting from here, the x-axis, counterclockwise. Let's try another example. All right, so this time let's say it's 3, comma, negative 130. All right, so first we see that the first number is 3, the radius is 3, so it's from the center, it's 3 units away, so it's 1, 2, and 3, so the third circle. And then we look at the theta, the angle. First thing you notice is this is a negative theta, and as I said, theta is the angle measured from the x-axis counterclockwise. But since this is a negative number, we go clockwise. Remember, if this number, theta, is positive, we go counterclockwise. If it's negative, we go counterclockwise. Then we see it's 130 degrees. So 130 degrees is somewhere about, we start from here and we go counterclockwise, and it's somewhere right here. Somewhere here. So as we said, it's on the third circle, so our point should be right here. Our radius is 3, so 3 units away. 1, 2, 3. Our theta is negative 130 degrees, and since it's a negative number, we go counterclockwise, and it's negative 130 degrees somewhere right here, so this is our point. All right, let's go over the last example. Root 5 pi over 6. So first of all, it's 2, so that means the radius is 2, so it's 2 units away. 1, 2, and the second circle. We can see that theta is a positive number, so we go counterclockwise from the x-axis. But one thing you should notice is that there is no degree symbol, so this is not in degrees. which means this is in radians instead. So if you know the unit circle, you can graph this using the unit circle, but we can also convert it to degrees. So to convert radians into degrees, we multiply them by 180 over pi. The pi's cancel out. We can simplify this. 30, 6 times 6 is 6 times 30 is 180. So this equals 150 degrees. And we know 150 degrees is less than 180 degrees, but more than 90 degrees. So it's in the second quadrant. So it's probably somewhere right here. So now we can plot our point. We know it's in the second, we know it's in the second circle since the radius is 2. 1, 2. So our point is right here. So if you see that the theta is in radians, you could convert it to degrees and then graph it. This is just the basics of polar coordinates. I just showed you guys how polar coordinates work and how it looks like. So you should have a slight understanding of how they're related to a graph, how they can be used as. So thank you guys for watching. And in the future, I'll post more about polar coordinates, how to convert from rectangular coordinates to polar or rectangular equations to polar and vice versa.